Hi, welcome to Nicola's Structural Analysis class. In this session, I would like to give a lecture on how to analyze a statically indeterminate plane truss. So first, we would like to know about what kind of determinacy that we can measure for a plane truss. Okay, first we can measure whether the truss is external determinate truss. Okay, we can measure the external determinacy of the truss, and second we can measure, okay, we can identify the internal determinacy of the trusses. So at first we are going to look into what it means by external determinacy. So we know that in coplanar analysis, okay, we can derive three simultaneous equations, okay, that is from the following equilibrium equation, where the total number of the forces at x direction or horizontal direction is equal to 0, the total number of force at y direction equal to 0, and the total number of moment at selected point should be equal to 0. So if the total unknown reaction, for example, we measure the truss, okay, for example, in previous class we already learned about, okay, the structure. Okay, we have the pin connection at this beam, and this is roller connection. So at pin connection we can have two reaction force here, while at roller connection we can have one reaction horizontal vertical reaction. Okay, so we have 1, 2 and 3 unknown reaction force. So means that these can be solved using a simultaneous equation. Okay, so how about if the unknown reaction, for example, we add another one. Okay, so now we have 4 unknown reaction. So in this case, okay, this equilibrium equation no longer can be used to solve for this unknown. Alright, so we need, later on we will see, okay, what are the methods that we can use to analyze, to identify the extra reaction force, okay, extra reaction force, okay, due to this external supports. Okay, so take a look into the example. Okay, I should drop this first. Okay, so take a look into this example. So in this example, okay, if we want to measure, if we want to determine whether the truss is externally determinate or indeterminate truss, okay, what we are going to look into is what the total number of unknown reaction, okay, due to the supports. Okay, for this truss, okay, it connected, okay, it connected by, okay, we have two supports, okay, at A and at H. Okay, at A we have pin support. Okay, we have pin support, and here we have roller support. So as we all know, okay, the pin support we have two unknown reaction, okay, at the horizontal and also both vertical reaction force, and at H, okay, based on this following condition, okay, the horizontal the force should be perpendicular to the direction of the roller. So means that we have horizontal vertical force at H at the roller. Okay, so now we have 1, 2 and 3 unknowns. So since, okay, we have 3 unknowns at reaction force, unknown reaction force at the support, so we can solve it using a simultaneous equation that can be derived from this equilibrium equation. Okay, so now the truss is considered as a externally determinate. Okay, later on we are going to look into the simple example. Okay, how it's look like for the truss with a indeterminate, external indeterminate truss. Okay, so another type of determinacy that we can measure for the truss is the internal determinacy. Okay, so if let's okay, so what is this abbreviation mean? Okay, these are the condition. Okay, condition that we can use to check whether the truss is stable. First, okay, if this condition is satisfied, means that the truss is unstable, and if unstable, so we no need to go further for the analysis, because unstable structure we cannot use it. Okay, we need to make sure the structure is stable, then be able to proceed further for the analysis. Okay, so another condition is these two. Okay, these two conditions must be satisfied, okay, for the truss to be a stable structure. So what is this abbreviation mean? So the M is represent the number of the internal members. Okay, J is the number of joint, and R is the number of external reaction. So let's take a look for a while. In this example, so this is a simple truss example, right? So this is the member. So how many members that we have? How many internal member that we have? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. We have 13 internal members, right? So in order to check the condition of the truss using this equation, right? So we have to, okay, we assume that we know that by assumption that we know that this truss is stable, so we just focusing on these two conditions. So J is the number of joint. So in order to complete this equation, this condition, we need number of joint. So we have joint 1, joint number 2 here, 3, 4, 5, 6, 7, 8. Okay, so we have 8 joints. So joint is the place where we connect the members. Yeah? So we have 8 joints here. So we need to put, okay, we need to calculate 2J minus R. Okay, so the number of reaction we know that 1 unknown reaction, 2 and 3. So we can use, okay, to check the condition of this, okay, of this truss. So we have 2J minus 3, which is equivalent to 13, and it satisfies the second condition here, means that the truss is internally indeterminate truss. So if the truss is internally determinate truss, okay, so when the truss is determinate truss, okay, internally determinate truss, we can proceed the analysis using using either you want to use there are 3 methods: the joint method, okay, we have joint method, section method, and also alternative method. But this truss must be both internally and externally determinate. Okay, so this truss is internally determinate. Okay, let's take a look when we add another members here. So we want to add another members that is connected to joint C and F. Okay, so now, so what is the total? Okay, the total number of joint are maintained. So we have 1, 2, 3, 4, 5, 6, 7, 8. However, for the total number of the members will be increased, okay, because the additional member already add. So we have 1 2 3 4 5 6 7 8 9 10 11 12 13 and 14. So we have 14, okay, we have 14 members, 8 join and still 3 reaction force, okay. So by completing the equation, okay, we found that the total member is greater than 2j minus 3. So this structure is, okay, we already know that the structure is externally determinate, but the structure is also internally determinate at, okay, at with degree of redundancy equal to 1, okay. So now the structure that we have, okay, the suppose, okay, to have a indeterminate structure, to have a determinate in to have a internally determinate truss. So you should have the total members equivalent to 14. However, now, no, 13. Okay. However, now we have member equal to 14. So it means that we have excess. Okay, we have excess member equal to 1, and this excess member also called as a redundant member, okay, redundant member. So if the structure is, okay, in this case we cannot analyze it using joint method, section method, and direct method or alternative method. So later on we will take a look into what kind of method, okay, something related with virtual analysis. Okay, another example we want to look here is this is a structure, okay, example of the truss that have external redundancy, means that this truss is externally indeterminate truss. Okay, take a look into this example. So, okay, determine the truss redundant number of redundant and state determinacy criteria for the given truss. So now we need to check the external redundancy, external redundant condition of the truss. So we know that the total number, okay, we have pin connected at this part, roller connection at this part, and roller connection at this part, okay, supports, okay, connection support and rollers. We have roller supports at these two parts, okay, and we have pin support at these two parts. So now we have okay, at pin we know that we have two unknowns of the reaction force. So we have 1, 2, and the total number of unknown that we have, okay, total number of unknown reaction force is 4, which is greater than 3, okay. So means that we have 1 excess 1 excess unknown reaction force, okay, 1 excess reaction force. So we measure it, okay, since the unknown reaction is greater than 3, so it considered as a externally determinate truss, okay, at 1 degree. So how about the internal determinacy of this truss? Okay, so we have 1, 2, 3, 4, 5, 6, 7. Okay, wait there. Need to up all this thing first. Okay, we have, okay, now we have, okay, reaction force, okay, members equal to 7, 1, 2, 3, 4, 5, 6, 7. Okay, so how about we complete this equation? 2, okay, we have 1, 2, 3, 4, 5 join. Okay, so 2j minus, we have 1, 2, 3, 4. So 7 minus 4 equal to 3. So when we measure this, okay, so we know that now we have, okay, m equal to 7. Okay, m is greater than, no, this is not 7, sorry, this is 10 minus 4, so we have 6 here. So m7 greater than 2j minus r. So this structure is considered as a internally indeterminate truss at 1 degree. Okay. Okay, take a look about the structure that have internal redundancy. Now the structure is okay, it has a 3 unknown force. So means that this is externally determinate. Okay, how about the internally determinate of this structure? Okay, internal redundancy of the structure. So we have, okay, now we calculate total number of member 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 members reaction and we have 6 nodes. Okay, 1, 2, 3, 4, 5, 6. Okay, we have 6 nodes here. And when we measure the equation, okay, so this is 2j minus r, okay, is equal to 9. So we have m greater than 2j minus r. So means that it's statically internally indeterminate truss with a degree of redundancy equal to 1. So you can use this method to determine the degree of redundancy by using m minus 2j minus r. This is one of the way that we can use. So the number of the redundant, okay, the excess members of the truss is 1. Okay, so why we need to use this indeterminate structure? Okay, the first reason is to ensure the stability of the structure. Okay, by imposing an external redundancy, okay, it can lowering down, okay, it can lowering down the number of stress that been imposed into the structure. Okay, okay, compared to the indeterminate structure, because it can aid, okay, it can absorb another stress. Okay, this external structure, external redundant reaction force can help to absorb, okay, the load can be distributed more into this part. Okay, so second is to increase the stiffness. By increasing the stiffness of the structure, okay, so it can reduce the deflection. For example, in this case, okay, so the structure will with determinate, okay, the structure with determinate support, okay, tend to deflect more compared to the structure with indeterminate, externally indeterminate support. Okay, we have the redundant excess. So here we have 1, 2, 3, 4, 5, 6. You see, we have more extra reaction force at more extra 3. Okay, it means that it can be reduced a lot. Okay, reducing a lot of the deflection. Simple example. Okay, so the question asks us to prove the truss whether it's externally, okay, prove the truss is external, statically indeterminate truss, okay. So, and also it asks to determine the reaction and internal force of the truss, okay. The given modulus of elasticity and the area are constant for all the members, okay. So it will simplify our process. Okay, so we take a look. Okay, now we have, okay, a pin support at A, roller support at G, and another roller support at E. Okay, so from here we know that, okay, the total number of the unknown forces, okay, unknown reaction force will be 4, because we have 1, 2, 3, 4. Okay, so 4 greater than 3, so means that the structure is externally indeterminate structure, okay, at 1 degree. Yeah, that's important. So we have one external force redundant over here. So this is the applied unit force, okay. Okay, we also need to check whether this structure is internally determinate or not, okay. So, okay, so from here, okay, we have the total number of members that we have. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, we have 13, and we have 4 reaction force, and we have 8 join. 1, 2, 3, 4, 5, 6, 7, 8. Okay, 8 join here. So by checking the condition using this method, okay, we found that this structure is, okay, this structure, okay, this is supposed to be 4, this is supposed to be R, okay. So the structure is a internally indeterminate. Okay, by the way, okay, later on we will reduce the support. Okay, we will reduce the support, okay, and the truss will become a statically indeterminate, okay, because the new members, okay, after we remove this, for example, okay, after we remove that, so the new members, okay, will become still same, okay, the new members still same, 13. However, okay, the total number of reaction R now become 3. So when we test using this equation, okay, this condition, so we met this requirement, and total number of member equal to 2j minus 3. So this structure is considered as a statically externally indeterminate and internally determinate. Okay, all right, so now the structure is become, okay, since truss is externally determinate, reduce the support reaction, so the structure is externally determinate. So we remove, okay, we will remove this, we select this, okay, we remove that, and this become, okay, this is the first structure. Okay, we choose G and apply 1 unit load here. Okay, so we have separate analysis for this. So analysis of this using the actual unit force by removing the external redundant reaction force. Okay, we will find for F bar here. Okay, and also here we will use the micron. Okay, so after removing G, then we can find for the F bar, F prime for each of these member here, right? Okay, and then this is to determine the micron, okay, the visual force analysis for 1 unit load, okay, due to the 1 unit load that we apply at the redundant forces here. Okay, all right, so here from this equation, okay, So this is the table that we can use. Okay, we use this table to simplify the process. All right. So we can see that each of these. Okay, this is member. Okay, this is column for member. Okay, each member we have the length, we have the area. Okay, if because since the area are constant, we can avoid, we can eliminate it. Even we can eliminate, no need to include here, but of course you can proceed with this, sure, no problem. So this is the force, the f prime. Okay, the f prime that we calculated, okay, based on the actual force after removing the redundant external force. And this is the unit force, okay, or the internal force due to the 1 unit, applied 1 unit force at the redundant external force. Then we perform this calculation to find for this. Okay, and another one is use this formula to calculate for this. Later on we will find total summation of this equation. So why there is a negative and positive value here? So at force, okay, the member force, okay, the force at the member, the internal force member F and U here. So the negatives means the structure, the member experience the compression, while the positive, the member experience tension. Okay, then after that, okay, when we able to calculate that, and we can find for Rg. So in previous, okay, so the Rg that we found is negative 56. What does it mean, negative 56? Okay, initially we assume, okay, not we assume the direction of the internal the reaction force is going downward because we apply 1 unit load downward. By the way, the result that we obtain here, the final result is negative value. Okay, means that pointing, okay, the different direction means that it going upwards. Okay, and after that, okay, we can use this value put into this equation. All right, put into this equation F equal to F prime. So F prime, okay, plus Rg times micron, okay, times micron here. So we have F prime, okay, this is the F prime plus Rg. So Rg is this value, okay, this value, use the negative, not this. So we need to use this times with a plus with Rg here, a plus with, okay, F times with the micron here, right, times with this. So F, okay, so we give the final value of the internal force member, right? So this is the real. So we now take a look into an example for a truss that having internal redundant, means that the truss is indeterminate, internally indeterminate truss. Okay, so the question asks us to classify the truss and determine the internal force. Okay, classify the truss means that determine whether the truss is externally determinate or indeterminate, or internally determinate or indeterminate truss. Okay, so given that the modulus elasticity E is constant, okay, constant for all the members, and cross-sectional area of A for each of the members are provided in the table here. Okay, it's provided in the table here. So some of the member, they have a similar size, similar dimension, similar area. Some of the some of the members, they have a different cross-sectional area. Okay, so we take a look. Okay, first we need to analyze, we need to study, we need to classify the truss. Okay, the determinacy of the truss. Okay, so we know that the truss is a external determinate truss. okay, because we have only 3 unknown forces, which is equivalent, can be solved using a 3 equilibrium equation. By the way, we need to know how many members that we have here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have members, okay, equal to 10, reaction equal to 3, and join we have 1, 2, 3, 4, 5, 6 join here. Okay, so it satisfies this condition. Okay, the total number of member is greater than 2j minus 3. How many degree that it differ? Okay, so m minus 2j minus 3, okay, will be equivalent to 1. So the truss is static. Okay, the truss having 1 internal redundant. Alright, so we can proceed with the analysis. Okay, so the first analysis is we use a real force. Okay, we use the real force to determine the internal force member. Okay, after removing the redundant internal member here. Okay, and another analysis that we need to perform is, okay, using a virtual force. We need to analyze, okay, we need to determine the internal force member. Okay, internal force member. Okay, the force member, okay, due to the one unit load that we apply to replace the internal redundant member here. Alright, then after that, so this is, okay, the analysis using a real force. Okay, and this will be the result, okay, by using a virtual force. Okay, so okay, we from here what we see is we have a lot of, this is zero force member. Alright, so after we do some analysis, we found that this is a zero force member. Right, no problem, it should be, sometimes we have zero force member in our structure. Okay, alright, then we use the table. Okay, we have this section, the member section, we have the length section with the area section, area length divided by area. Okay, so we can determine all these. Okay, we use the table to simplify the process. Okay, so we can see here, for example, the member F. Okay, so the internal force member due to the real force, okay, after removing the redundant members is 15, and the the internal force, okay, the member force, okay, due to the 1 unit load is 0 force member. We take a look where is AF. So AF, okay, so this is AF for the internal force member for the virtual force, and another one is AF, this is 15. Okay, the sign is positive because the member experience tension here. Alright, okay, let's take a look into BC here. Okay, BC here. So we found that the value of F prime and also the micron mu here is negative, both have negative. So take a look and check it, BC. So we have BC. So BC, okay, from this notation, we know that this member experience compression. That's why we have the negative in front of the number here. Okay, the sign of the number is negative. Also similar with this. Okay, so this is negative here. Right, so that's why we have a negative sign in front of the value here. Alright, then we perform, okay, as usual. Okay, before we find for this, before this is letter, this is the last stage, last stage. Okay, so we will find the total number of prime UL divided by A, prime mu L divided by A, mu square L divided by A. Okay, then we find the summation, then we can find the internal force here. So we found that the internal force for the redundant member is a 2.16, which is positive value. Means that our assumption that this member experience compression is correct. All right, is correct. So then the direction is the sign here we have is positive. So we use, okay, we will use the, okay, this value will be included in this equation. Okay, so we can see this is the calculated internal forces. Okay, and we can find for the, okay, the actual internal forces. Okay, so this is the our final answer.